welcome back guys, you are watching Rising Code Era, and in the previous video we have just seen what is a linear search, a searching algorithm, which is a basic searching algorithm. And in this video we are going to see what is a binary search. So what is a binary search? And before moving ahead, if you have not subscribed to the channel, please get subscribed to the channel. And I hope that you know what is a linear search. If you don't know, please watch the previous video so that it will be more easy to understand the binary search. Okay, so I've just completed it inside the previous video. Okay, so what is a binary search? So what is the thing? You need a sorted array, guys. I have just written here also at the top that note array must be sorted. So we will take an array and it will be sorted. It should be sorted, okay, in ascending order only. Okay, so what is the first condition, guys? That we need an array and which should be sorted. Okay, the array must be sorted. That means it should be in ascending order from smaller number to the greatest number. Okay, now what will happen? We just have to search for a particular number inside this array, which is going to be your target. You can see it target, you can see it key, as per your choice. Okay, so right now if you see, divide the array and find the mid. So what we will do, first step, we are going to find the mid value. So what we will be doing, we are just going to do this left and this is going to be your right. We are just going to assume it and we will say 0 plus 4 divided by 2, you will get the midpoint. So this will be stored inside this variable. Now the next thing you need to do, and after getting the mid, we are just going to check the first condition, that we are going to check that whether the mid value is equal to the target value. So we are going to have a target value. Suppose that the target value is 20. At this point you can just see the target value is 20. And right now if we see what is the mid according to this array, if we see, okay, according to this array, if we see, so what is the mid? So this will be your mid. This will be your mid. Okay, so at the 2 index the mid value is 30 and our target value is 20. So what it will show that, so this condition will get false, guys. Okay, this condition will get false, and if the value is equal to 20, that means the target is present at this value. Suppose that it is 20, then it will be returning the index number. So it will be returning the index number at that point. So if you see here, if it is 20 and if we are just getting it at the first try only, then it is really a good condition. Okay, so you will get the mid, you will be returning the index value. I've just written here. And if it is not there, then what you have to do, we are just going to see there are two conditions for that. If it is not there, it may be happen that the element is not there inside the array. So we will also see that one condition. And if the number is greater, then what we will be doing. If it is lesser, then what? So what will happen if the target value is greater than the mid, then what we are going to do? Suppose for right now we are just having a target which is a 40. So target value is 40 and you got this 40 you got. Now what we can do, we will just say left plus right divided by 2, you will get the mid value which is 2. So if we see the mid value is less than the target value, okay, so 30 is less than 40. So what we will say, we will just search at this point because we know that this will not help us. Okay, this will not help us because this is the lesser value and we know the array is sorted. So what we will be doing, we will just searching at the right side. If we are going to search from this to this, then we are just wasting our or the machine time. Okay, you can just say we are just reducing this time. Okay, so that it will be working more faster. So what we will be doing, we will search at the right side. When it is, if the mid value is less than the target value, we will be searching at the right side. Okay, and if it is not, that means it is smaller, then we will searching to the left side. That's all. So that is the condition, we will be seeing it. So if you see right now, we are just having the target as 40 and we got the mid which is 30. So mid is 30 which is lesser and our target is more. Okay, so if we are going to search this, then we are just wasting our time. So we will not search at this point because we know that the element is not there, and as the array is sorted, it will be at the right side only. So we will say mid will be mid plus 1. Okay, so this will be your left. So this will be left at this point and this will be right. Right will be at that point only and the left will be updated. So how it will be updated? We will say left is equal to mid plus 1. So what will happen? This is going to be left. Right now what we will be checking? We will be checking this 2. Okay, then again we will be dividing it with 2 and you will get the 3. You will just repeat this step again, divide and then check the value if it is matching to the mid. So what happens at a particular point, you get the mid value equal to the target value at one point. If it is not there, then consider that the element is not present inside that array. So right now if you see, if target value is smaller than mid, ignore right side. So we are just going to say right now, if I'm just searching for the value, if you see target is 20. Now I just got the mid value which is going to be the same condition, left plus right divided by 2, you get 2. And when you get the 2, what will happen? Your mid value is right now 30, your target value is 20, the mid value is greater. Okay, mid value is greater. So what I will be doing, I will not search the right side, because right side all the numbers should be array sorted. Again, the array sorted. So what we will be doing, we will just shift this mid to this point. So we will say the right will be updated at this point. We will say right is equal to mid minus 1. Okay, so it will be mid minus 1, and we will not search this. Okay, we will be not searching this. So we will be searching only 10 and 20. Okay, so okay, we will be searching only these numbers 10 and 20, and again we will be dividing it, and we will just check whether the mid value is equal to or lesser than, and this condition gets repeated until and unless we get the mid value equal to target. If it is not there, we will be returning -1. That means we will say that the array is not having that number. Now here if you see, we have just done the same process. We have just skipped this point because right side values are greater. Right is equal to mid -1, we will say. If the element is not present, then we will be returning -1. So how we will be doing it? We will just see it inside the code, guys. Now what is a binary search? You need to create first the array. So I will just create an array, integer arr is equal to, inside this we will be passing the values 10, 20, 30, 40. Okay, right now we have been created the array, and the two things which we are just required, and that is going to be the target value and arr, that means the array name. We are going to pass in one method, and we will be giving it name as, suppose we will give the name for that particular method, and it is going to be binary search. Okay, so this will be the method name, and what we will be doing, we will pass two values. The first thing we are just going to pass, and that is going to be the array, and the second thing we are just going to give it, and that is going to be the target value. Okay, so right now let's create the target here, so which is going to be the of integer type, and suppose we are just going to search for the number, and that is 20. So for that, okay, so what we will be doing, we will be just creating the method at this point. So I will just say main, and here we will, okay, we are just going to return an integer value basically here, and the method name, if you see, it is going to be the binary search. So it is going to be binary search, guys, and right now we are just going to write this parameter. So first one is going to be your integer of array, and the second one is going to be the integer which is going to be your target. Okay, where it is just moving anywhere, no problem. So it is going to be the target, guys. It is going to be target. So you got the binary search, you got the target, and everything is fine. So first thing we need, and that is going to be your left value, because you know we are just going to start from the left, and at the point, you know, the left index is all the time 0. So if we are just going to say that this is going to be the left, and the first index of the array is all the time 0. Then next thing we are just going to say int right. Now what is a right? Right is nothing but it will be your array.length. So it is going to be arr.length. Okay, why? So what will happen? It will be dot length -1. The reason behind that is, if you see, so it will be starting from 0, 1, 2, 3, 4. So it will be 5 minus 1. That means 4, because your indexing is going to start from 0, 1, 2, 3, 4. Okay, that's all. Now we will be using a while loop. Now why we are going to use a while loop? Because we are having a condition that left is going to be lesser than equal to right. In this loop only we are going to write the condition. Now why we have just written left is less than equal to right? The reason behind that is, you know that at certain point what will happen, this is going to be your left, this is going to be right, assume that, and we will calculate the midpoint, which will be this. At the end there will be only a particular number which is going to be the left, and it is also going to be the right. So we will say we want to move up to less than equal to. Okay, we will just calculate the mid. So for that I can just write int mid is equal to formula for this. So you will say left plus right, and you will be dividing it with 2. So that's all, and it will be stored inside the mid. So right now guys, what I have just done, I have just created a result variable which will be storing all the things from here, and if you have to print, you can just print it from here. Okay, let's erase this as well, we don't want this. All right guys, I've just created some comments. So check if target is present at mid. We will just writing for this that if mid value and the target value is equal. So at that point what we will be doing, we are just going to return the mid value. So what will happen, we will say array of mid, because we want the value, not the index number. Okay, if it is equal to, if it is equal to, we are just going to say to the target value, then we are just going to return the mid. That's all. So that what will happen, it will return the index. Basically we know that we are just going to return the index. The next thing we are just going to do, and we are just going to see if target is greater than ignore left half. So for this what we are just going to do, we are just going to say if, okay, we are just going to say array of mid if target is greater, so what is going to happen? Okay, so mid value is smaller and the target value we are just estimating that is 40, so we'll be searching at the right side. Okay, so what will happen? Mid we are just going to update and it will be mid plus 1 is going to be your left, so left value is going to be your mid plus 1, so your left value is going to be updated, so you will say left is equal to mid plus 1, so mid plus 1. So that's all, we have just completed this condition, so it is just updated. Okay, the next thing, if target is smaller, ignore right half. So for this what we can do, we can just say that else statement, or you can just write else if, you can just use if, inside there will be a condition. So what we will be doing, so what is this condition? Let's see. Now you are just searching for a target value and you find that the mid value is greater than the target value. So for this what will happen, we will say we will just update the right, it will be at this point, because we will search for the smallest number which is going to be at the left side, not the right side. So we are just going to skip this part. So we will say right is equal to mid minus 1. And if you not get the target, we will be outside the loop. So what we'll be doing, we will just copy this. If we will not get the number, so at this point what we will be doing, we will be outside the loop and here we will return the value, and that is going to be our minus 1. That's all. So I think we have just been done with this and it's time to run the code. Okay, I will just close this. So right now we have just done it and I will just say here south, and for right now we are just going to see the result, that whether it is working or not. So we will say result and we will just run the code. You got the one index, at one index it is 20 present. Okay, so yeah, it is present 0 and then you get the 1. Right now we will be changing it to the 50, so it will be at which index we will just try to find out. So it will be at 4th index, I think. So this will be 0, then this will be 1, this will be 2, 3, 4. So 4th index 50 is present. So yeah, 50. What if the number is not there? So I will just do it 90, okay, which is not present inside the array. It should return minus 1, guys. So let's see whether it is going to return you minus 1. Okay, it is working fine. It is also returning minus 1. Okay, so everything is working fine. You can just test it. Now if what the 30, that means the mid value we will be taking, will it return? It will return 100%, it will be returning. Then also we will be checking. So it is present at 2 index. Okay, so yeah, 2 is also printing. If the result value is not equal to, if it is not equal to minus 1, then we will say something is there, that means return something. Okay, return some value, that means it is going to return the index number. So for this what we are going to do, we are just going to, okay, so this will just return. Let's see how it will be running. So I will just run the code and let's see what it will be returning. So it will say element 30 found at index 2. Now what if it is going to return the minus 1? So for this we will just say the else. For right now I will just say here that element not found. Okay, not found, we will be writing this. Okay, so let's make it string, and that's all. So if I'm just going to enter a number which is not there, so for example I will just return a 0, so it will be returning that element not found. So that's all, guys. Okay, you just understand this concept, and now it's time to see the time complexity for the binary search. Right now, guys, we are going to see what is the time complexity for this. And if you see the time complexity, so for the best case it is going to be O of n, that means O of 1. Okay, and for the average case and worst case it is going to be O log n. But if we are just going to search for a binary search and we are just having a lot of numbers, suppose we are having 1,000 numbers and at mid value only it is present, the number is present at the mid value only, so that means it is present. Suppose this is the mid value, it is 500 position and at this point only it is present, we got this value at the first attempt only, so you will get O of 1. Okay, it is going to be O of 1 for the best case. Okay, so target element is in the middle of an array, so we are just going to say O of 1. Now what is average case? When we talk of an average case, so what happens, the element is present at very far. Okay, you need to do a lot of operations on it. Suppose you don't get it in first attempt, then second, then third. So what happens when we talk about the binary search, it is going to be O log of n, number of comparison growing logarithmically with the size of n. Now when this size, that means it depend upon the array size. So if you are having a small size, suppose I'm just having these two arrays. Okay, I'm just having the two numbers, suppose 2 and 6, so it will be more easy to find the number. Now what if the array is huge? So at this point it will be skipping some time. Okay, we are just reducing some time as well. So it depends upon the size of the array as well. It is going to grow, that means the time complexity will be growing, but it will be growing very slowly. Binary search is more efficient algorithm for finding an elements in a sorted array. It works by repeatedly dividing the search intervals in half, making it much faster than linear search for large data sets. Now you have to note that you are just going to do it inside the ascending order. So that's all guys for today's video. So that's all guys, this is all about the binary search, and if you are not subscribed to the channel, please get subscribed to the channel